Welcome. In this video, we're going to talk about a little bit more about factoring. For example, when A is not 1. Well, what do I mean by that? I'll show you. So in previous examples, we've seen something like this, where it's, say something like what's going on here? X squared plus, I don't know, 5x plus 6, right? And this can easily be factored as long as you know your multiplication facts, right? If you know how to break up 6 into a factor pair, we can say, well, we know that 2 times 3 is 6. So if we did it like this and we said, all right, I'm going to find two numbers that multiply to get 6. Well, I can either do 1 and 5 or 2 and 3. And we just kind of do some simple calculations here. 1 and 6, I should say, is 6 right there. 1 times 6. And so if we do 1 times 6, that's 6, but if we add them together, that's equal to 7. If we do 2 times 3, we add them together, that's going to get, so multiply to get 6, but adds to get 5, which is exactly what we want, right? So that's pretty simple. Now we can just write the factor like this. So we factored it just by doing some quick calculations right here. And that's when A is equal to 1, meaning when we have nothing that we see in front of that x squared, we know that's a 1. However, what we're going to see is what happens when it is not, it's something other than 1. So let's take a look at an example here. Let's say we have something like this. Maybe it's, here I had some examples ready to go. Let's say we had something like 2x squared plus 7x plus 3. All right. So if we had this and I said, all right, let's factor it, then what would we do? Well, actually the process is pretty similar. It's very similar. However, there is a step in the very beginning that we have to do. For example, we have to take our first coefficient right here and our last coefficient and multiply them together. So what we do is when we multiply them together, right there, 2 times 3, that is going to be the number that we use to find our pair. For example, that's the number that we're going to use to find our factor pairs, like in this first example. So you multiply the first and last number, the first and last coefficient. I'm going to write a list of steps here at the end, but this is just an example. So there we go. Now let's go ahead and write, all right, now everything else is the same. Let's go ahead and write our factors, our factor pairs. We know that 2 and 3, 6 and 1. Those are the only pairs that are going to work. So if I add these together, 2 plus 3 is 5. So we know that won't work because they still have to add to get our middle coefficient of 7. Well, what if we get 6 plus 1? That's 7. Look at that. So now we can use 6 and 1 and think about what happens when we distribute. Okay, when we distribute, what happens is, let's move this a little bit right there. And what happens when we distribute, say if we have something like this right here, the x plus 2 times x plus 3, you're going to have some middle terms that you combine, that you add when you simplify. Let's think about the opposite of that. Okay, let's break apart this 7x. Let's break apart this 7x right there into our two numbers that we decided would work. So let's go ahead and rewrite our expression. 2x squared plus, and I'm going to do this at the end, okay? And I have plus 3 at the end. We're going to break apart that 7x into the two numbers that we decided were going to work. So for example, we have a plus 6x and a plus 1x. We know this is going to work, right? So 6 plus 1 is 7. We're just breaking apart that middle term, okay? So let's see what we have now. We have 2x squared plus 6x plus 1x plus 3. Okay, so what we can do now is called factoring by grouping. Really easy. When we factor by grouping, think about finding a GCF between the two pairs. If we kind of split our problem in half right down the middle, we can factor a GCF out of each of these pairs of terms. So for example, let's look at this first one right here. If we have 2x squared plus 6x, one thing we can think about is, what does 2 and 6 both have in common? Well, I know that they both have a 2, so I can divide out a 2, and they both have an x. So we know that we can only take out one x right there, since that's, that 6x only has 1, so we can only take out an x right there. What happens if we divide each of these terms by 2x? What's left over? So if I divide the 2x squared by 2x, well, the 2's, so those 2's are going to cancel, and we're going to get a 1. And I'm just left with a single x right there. So I'm just left with that x, right? Because x squared divided by x, well, one of the x is going to cancel, leaving 1 left over. And then we have plus 6x. So let's look at our numbers. 6 divided by 2 is 3. We're at a positive 3. And then we have x divided by x. That's going to be, well, there's no x's left, right? They both cancel out. Okay. So we have x plus 3 as that kind of that leftover, what's in the parentheses when we divide out this 2x greatest common factor. Let's do the same thing here now. All right, what happens when what can we take out of 1x and 3? Okay, let's treat this as a separate greatest common factor problem. What happens here? Well, 1x and 3, the only thing they really have in common is a 1, so we can only take out a 1. And they don't have an x, so we can't even take out an x from this, right? This has an x, but that doesn't. So what we're doing here is just taking out a 1. That is still a number you can divide out of it, each term. Okay, so what's left when we divide each term by 1? Well, nothing is going to change, right? When you divide by 1, it doesn't change. So we have an x plus 3 left over, right? Because if you were to redistribute, you would get 1x plus 3, which is what we had right here, 1x plus 3. You can always redistribute and check if it's the same answer. All right, this is the key part right here. We have to notice, what do we have in common? Well, what we have in common is that x plus 3. That will always happen. You're always going to have a common factor inside of those parentheses. What happens here now is you can factor this out and say, okay, well, x plus 3 is my common factor. So what happens when I factor that out? Well, let's see. We have x plus 3. And now we can go ahead and cancel that since we already divided that out. And what's left over after canceling that out? Well, our leftover terms are 2x plus 1. And so this is our factored form of the original expression, 2x squared plus 7x plus 3. I'll zoom out so you can see all of it. So there we go. It's a little bit of extra work, but once you get right here, that part should be familiar. And then right here, the factoring by grouping is just some extra practice. We'll do a lot of examples with that. So this video is just to introduce a concept. Maybe I'll make another video just getting some extra practice problems that you can do alongside as I'm doing it. If you have questions after watching this, let me know. Otherwise, I'm going to create a new video, and that will be it.